Hello, today we're going to be taking a look at the difference between verifying and proving trig identities. Now, we can use this with some of the simpler trig identities that we have and that we're going to use frequently, like our half-angle identities, our double-angle identities, Pythagorean identities. But most of these other ones that we're going to look at here are just other identities that work that we're just going to prove why they work. Now, for verifying an identity, this only works when we're substituting in one specific value. So for example, in this first one where we're trying to prove this identity, well, we're going to verify. We'll prove it in a minute. If we just substitute in 0 for x, so we have secant of 0 minus tangent of 0 multiplied by sine of 0 is equal to 1 divided by secant of 0. Secant of 0 is 1. Tangent of 0 is 0. Sine of 0 is 0. So 1 minus 0 is 1. Great. We've shown that this identity works for that specific value. That's not good enough. We need to use other identities and algebra properties to show that this works for every value. So what we're going to do with this is either work with both sides of the equation for the identity, or we're going to deal with one side on its own and get it to look like the right side. Now, this first one, let's deal with both sides. Some of these, it's going to be easiest to just work in terms of sine and cosine. Others, it'll be easiest to work in others. This one, we're going to do all in terms of sine and cosine, and we're going to work with both sides of the equation. So here, let's rewrite this in terms of sine and cosine. Don't forget your x or your theta or whatever variable we're using. So here, secant of x is 1 divided by cosine of x. Tangent of x is sine of x divided by cosine of x. And then we still have that multiplied by sine of x equals 1 divided by cosine of x. Now, what we can do here is combine terms on our left side. So we have 1 divided by cosine of x, 1 minus sine squared x divided by cosine of x, because our sine of x is multiply here. We have a common denominator, so we can combine them. And that's going to be equal to 1 divided by cosine of x. Or, sorry, it's not 1 divided by cosine of x. It's just cosine of x. I'm thinking of a different problem. So it's just cosine of x. So what we can do here is multiply both sides of this equation by cosine of x, and it will factor out with this denominator here. So we're left with 1 minus sine squared x, and then this right-hand side will be cosine squared x. Since this is a Pythagorean identity, then we're done. We've proven that identity through these uses of algebra properties and other identities. For this second one, we're going to work with just the right side and get that to be equal to the left side. So here we'll write RHS, or write out right side. This is right-hand side. And we're just going to try and get that to look like this 1 plus cosine of x divided by sine of x. So, first thing I want to do, we have cosecant of x plus cotangent of x, is rewrite everything in terms of sine and cosine. So, cosecant of x is 1 divided by sine of x. Cotangent of x is cosine of x divided by sine of x. Since they have a common denominator, we can combine them. Now, since this is the same as the left-hand side, we have proven that identity. Some of these are going to be a little more involved than others, and some, like that one, just take 1 or 2 steps and we're done. This one, I want to work with the left-hand side. Typically, if we're working with one of the sides, we're going to work with the most complicated side and try and get that to... it's easier to get the more complicated side simpler to look like the other side than make the simpler side more complicated. So for our left-hand side, let's write this in terms of, well, let's write that secant in terms of cosine. So secant of theta is 1 divided by cosine of theta. That's what I was thinking of on number 1. And then we have our tangent of theta plus cotangent of theta. Actually, this one, to make life a little easier, let's rewrite that cotangent of theta as 1 divided by tangent of theta. So our numerator is going to be tangent of theta. And then our denominator, what we want to do is get a common denominator so that we can combine these. Okay, so we'll have a tangent squared theta plus 1 divided by tangent of theta. Then what we can do, since we're dividing by a fraction, we can multiply by the reciprocal. All right. So then we have tangent squared theta divided by tangent squared theta plus 1. But what we want to do is turn that into secant squared theta. Okay, so we've used a Pythagorean identity for this step. So then what we can do is write everything in terms of sine and cosine. So tangent squared theta is sine squared theta divided by cosine squared theta. Secant of theta is 1 divided by cosine of theta, and don't forget that they're squared. So then what will happen is we'll multiply by the reciprocal of the denominator. We can factor out our cosine squared thetas. And since sine squared theta is the same as the right-hand side, we are done. We've checked this one off. Now, you could also do this one in terms of sine and cosine from the start. There is more than one correct way to do these. Now, we're going to look at one more here. And here we've got secant of theta divided by cosine theta minus tangent theta divided by cotangent theta is equal to 1. Let's start simplifying the left-hand side and see where that takes us. So secant of theta is 1 divided by cosine of theta divided by cosine of theta minus, well, what I want to do here is, well, we've got our sine of theta divided by cosine of theta. Let's work with both sides on this one. Okay, so we've written everything in terms of sine and cosine. So then let's start simplifying some of these. So what happens here, we have 1 divided by cosine squared theta. Here, we multiply by the reciprocal. All right, so we've got a few different options once we simplify this one. Now, one of our options is to just work with the left side and combine like terms. So we have common denominator here. So 1 minus sine squared theta divided by cosine squared theta. This numerator is a Pythagorean identity for cosine squared theta, which is equal to 1. And that's the same as the right-hand side. The other option we have to prove this identity is to work with both sides. So if we were to take from this step and multiply both sides by cosine squared theta, this term would just become 1. This term, the cosine squared thetas would factor out, and we'd be left with sine squared theta. And this side would just be cosine squared theta. So with that, this is a Pythagorean identity, so we have proven the identity. So what we want to do with these is work either with one side or both sides, use identities, use theorems, use algebra properties to either get both sides to be the same thing or to get it to the point of one of our basic identities.